Hi, and welcome to Sensors Converge 2022 here in San Jose, California. I'm your host, Ulysses Iñiguez for Microchip Technology, and we're here at booth 218. If you're in the area, come check out our demos and our booth experts. But if you can't come, you can go to www.microchip.com/Sensors Converge to learn more. Now today, we're talking to Mark Smith, one of our booth experts. Mark, for your demo, what is an inductive position sensor?
Yeah, so today we're showing these inductive position sensors, and I really like the technology. The sensor itself is traces on a PCB board. And we just put traces on this PCB board, and then by doing that, we can detect, and controlling those traces, we can detect the location of a piece of metal. So we have simple metal targets and traces on a PCB board. And we can do, this is, for example, a linear sensor, but we can do rotary type sensors. And the way it works, which is pretty interesting, is we're exciting a magnetic field, like the primary of a transformer. And we have two receive coils that are detecting that magnetic field. And this metal that gets placed inside this magnetic field gets disturbed. It gets induced eddy currents that are conducting in a way that cancels the magnetic field. It disturbs the magnetic field. And those two receive coils then triangulate the position or they get different voltages that allow us to triangulate the position of that target. So it can be very accurate, about 12 bits of resolution for some of our ICs, and we can go even higher if you add more analog to digital converter resolution to it.
Awesome, and what applications can we use this for?
Yeah, so anywhere you need robust, noise immune, linear or rotor or angular position, it would work. You know, a robot, angle, all the axis rotations of a robot. Linear movement does really well. You can scale it from being really small, or you can make it be really long too. We've had sensors we've designed that are 600 millimeters, a couple feet. We've done sensors that are just a few millimeters in length. I got a couple of cool applications right here. This is a couple car applications that would be inside your car. Your accelerator pedal has a couple sensors in it. Most likely they are actually inductive position sensors. And we're measuring the angle of this pedal here. And that would go into some sort of ECU. In this case, we have one of our DS-PIC motor control boards here that's reading the sensor's position. And then we're controlling a throttle body. The throttle body is that air intake valve that's on the top of your internal combustion engine. And we're controlling the angle, and we have a sensor that's inside here that's actually detecting the angle. So we are actively controlling that angle here. These are two examples taking advantage of the technology. You can see this is a high temperature environment for a throttle body right on top of your engine, okay? Or a safety critical application like your pedal. These are where this technology really strives.
Okay, awesome. And what are the benefits versus other technologies out there?
Yeah, the simple three that I always say are accuracy. There's no hysteresis that needs to be involved that you might see with maybe a magnet type based solution. We don't use magnets, and that's the other advantage. There is no magnet involved. We don't have to source them, the cost associated with the magnets. This is just using something that conducts metal. We like to use copper, aluminum, stainless steel. Those are two. And the other one is that we're immune to stray magnetic fields. Now there's some nice advantages to that. One is we can go into an environment where there are a lot of new magnetic fields. An electric vehicle, electric scooter bike, whereas before you wouldn't have those types of magnetic fields when you're using your traditional internal combustion engine. Today, those magnetic fields are all around. And so we can reject those magnetic fields. Another nice advantage is that for motor control applications, we can put the sensor right next to that motor. The motor has magnetic fields in it, but our sensor is not as immune to those fields that it's creating and is just being used to measure position.
Yeah, that makes sense. And do you have anything new to show us today?
Yeah, so at our show a couple of months ago, just released is our new motor control sensing device called the LX34070. So it expands our portfolio of products from, human speed, power assist type applications into motor speed applications. And of course, the question people ask is, well, how fast of a motor? We can do really very fast type motors. And the device right here, here's the demonstration board that we have. And this is an evaluation board for a 90-degree mechanical sensor that would be paired very nicely with a 4-pole pair motor. And we can do really any speed motor. Most of the typical industrial application speeds that you need, we can handle here very nicely. And that's what's shown today at our show. So.
Well, thank you, Mark.
You're welcome.
Thank you for showing this today. And for our audience, if you're here in the area, again, we're at booth 218. And if you're online, please check us out at www.microchip.com/Sensors Converge. And we'll see you next time.